In this video, we're going to do a quick little review of a stack proof for K for extra practice if you want it. So right now, pause the video and take a look at the picture, and we're going to see how you do on it, and then we'll go ahead and show you how to do it. All right, let's take a look at how this was done, and you can check your work to see if you're able to do it right. So your given is that segment BC is parallel AD, and that BE is congruent to ED. So you got parallel, parallel, congruent, congruent there. Because these lines are parallel to each other and cut by a transversal, you know angle CBE, I'm sorry, we're going to go on that side. That's the way I have my proof. Angle CBE is congruent to angle ADE by alternate angles. And you know what? These right here are vertical angles. Now, in your proof, you might have said angle BCA is congruent to angle DAC. That would also be correct. I just chose this left side and this right side here. And so if I join these three together, I say triangle BCE is congruent to triangle DAE by angle side congruence. Actually, I have that wrong there. It is actually going to be by angle side angle congruence. I'm sorry about that, because you have an angle, a side, and an angle. If you had chosen both parallel lines, so using this angle and this angle as well, you would have had AAS. But if you choose the vertical angle, you have to go with ASA on that one. So if triangle BCE is congruent to triangle DAE, you know that by corresponding parts that segment CE is congruent to segment AE. And you also know that vertical angles here are going to be congruent. So using the vertical angles, the original BE is congruent to ED, and the corresponding parts, you can prove that triangle BEA is congruent to triangle DEC by side angle side congruence. And if those two triangles are congruent, then BA is congruent to DC by corresponding parts.